Alright, so as you see, it's the parent seminar on brain. Good afternoon, welcome. Now I'm here not to tell you about parenting because I got everything right. I'm a normal parent, just like you are, and in fact I did my fair share of yelling and nagging and complaining and grumping, and I think Ray was a parent better than I did. So I'm certainly not here to say I got it right, because I didn't. Certainly not every day. And I'm not here to tell you about the brain because I know it all. That's not the reason that we're here either. I don't have all the answers. Kids 32 years ago, when our first one was born, kids were complex back then. But I still teach, and I'm thinking that kids are even far more complex today. I think there's a lot more influence. I think there's a lot more happening in families. For example, when I first started teaching, there wasn't not one child in my classroom that came from a divorced family. Changed, hasn't it? 32 years. So I'm not here to tell you that I know it all, have all the answers for you, but what I do want to present to you is some really interesting facts I've been learning at uni. I'm in my third year of Master of Counselling. I'm specialising in neuropsychotherapy. Neuropsychotherapy is a combination and integration of neuroscience and psychology. And I'm studying at UQ and I go on placement next year. I've teamed up with a psychologist and we're actually running seminars in schools. We're doing parent seminars. We do also admin seminars for corporations because there's a lot of the issues that we talk about today that you'll see right across the board. If anyone's interested, I've got some flyers there, particularly those for schools here at the moment. So the guy I've teamed up with, his name is Matthew Darlitz, and he's actually the editor of the Neuropsychotherapy magazine. All right, let's begin. Here's our brain. We're going to have a quick overview of what we're doing today. We're going to talk very briefly about what is the brain. Now, because this is a parent seminar, there's not going to be a whole lot of facts and figures. You know, the brain's complex. We'll do a little bit of the brain overview because if you were anything like me, I failed high school biology. Not proud of that, but I did. So if you're anything like me, you might think, oh, that's a good little refresher course. We're going to look at how the brain develops. Then we're going to look at some basic psychological needs, which actually are the hinge. They form the hinge that are the basis of behaviours. And this will actually answer a lot of your questions about why kids act the way they do, why adults act the way they do, why your boss acts the way he does. And it's all about thriving. So hopefully when you finish here, it's not just about kids that survive. We want to have kids that thrive. Anyone can survive, basically. But you want kids that actually thrive and get on in this life. All right, after that, part two, have a little break. Part two, we're going to do some practical applications to some very specific situations, and we're going to look at those things that we talked about in the flyer, lying, general behaviours that are annoying to us as parents, and some of them are downright bad. And we're going to look at some practical applications, and I just want you actually this afternoon to probably be aware. Awareness is really important. Because if you're not aware, you can't change behaviours and you can't change anything if you're not quite sure what you're changing. And it reminds me very much of a story. Well, Ray came home and told me this. Ray does the shopping. While I'm studying, Ray shops. So he was doing the grocery shopping and he came home and he said, the funniest thing happened today. So I'm shopping in the supermarket and he said there's a lady there and she has two kids and one of the little boys is in the top of the trolley and he's busy pulling stuff out, putting as much into the trolley as he can, and the little girl's having an amazing time and she's doing the pirouettes and the cartwheels and the circles all around the supermarket aisles, as you can imagine. And Ray said she got to the stage and she actually did a little circle and she bumped into my trolley. And with that, the mother turned around and said, Chloe, you just have to be aware. You must be aware when you're out and see the situation that you're in. You must be aware. And Ray said, I looked up the lady and she had her shirt on inside out. So maybe it's genetic, don't know. So I'm hoping I can turn your shirts the right way around today and that you will be aware. All right, so what is the brain? Very brief overview. There's so much out there about how the brain has billions of neurons and trillions of connections, but this is going to be a very simplistic presentation and it's going to be practical so you can take things away with you. So
I was just talking to Peter before, and he said, things have changed a lot to when we first knew about the brain. And that is so true. I do remember in biology class that if you killed off your brain cells, you were told, that was it. And you actually didn't really progress from there. And it was very interesting when Ray's mum, 20 years ago? Ray's mum suffered a stroke 20 years ago, and she paralysed down one side, drooling at the mouth, a typical stroke victim, was in a hospital for rehabilitation, but she overheard the doctor talk to Ray's dad just outside her room, and the doctor said, well, this is as far as Jean's going to go with her rehabilitation. She's really not going to get any better than this. You'll just have to come to terms that when you take her home, she will be paralysed. Yes, she will have problems eating, she won't be able to feed herself, but that's as far as she'll go. She overheard that, and I'm sure you're very aware that there is great power over what we believe. Within 48 hours, Grandma Ferry was dead. Because she had always said to the family, if I ever get in a state where I cannot look after myself, I want to die. And she did. 48 hours she died. There was no other reason. It's amazing what our brain does, isn't it? So what we used to believe about the brain actually is not... This is very uncomfortable. I get to just shift this. What we used to once believe about the brain, it does compensate and it does adapt. I just might even hold it. Thank you. I just might hold it in my little hand. So, sad story for Ray's mum, and I think if she'd been alive today and she'd had the stroke, what they do in stroke victims now, if you have a stroke on one side, they'll actually tie up your good side. They'll put in a sling. So you must learn to use the side that's been affected by the stroke, because your neurons can change. They change the pathways, and you can learn to do behaviours and learn to do things that you didn't think you could do because your brain compensates. And if you want to know how far the brain compensates, read the books by Norman Doidge. Norman Doidge wrote The Brain That Changes Itself, and he's also written another book out now called, I've forgotten the name of it, but he's got a new one out. It's actually called The Brain's Way of Healing by Norman Doidge. And there are so many examples in there of how the brain has actually changed itself. And you'll see I've left paper and pens on the tables. Feel free to use them to write down anything, won't you? All right, so we'll talk about plasticity a little bit later on. Now, there was a guy called Eric Kandel. Eric Kandel, he was actually from Vienna, I think it was, and he studied the giant sea snail, which is called the aplysia. And the aplysia is a very unusual snail because it has very, very, very large neurons. And these neurons could actually be isolated. Usually they're so close together that you can't actually tease them apart, but he could actually tease these apart, and he isolated these large neurons which you could actually see with the naked eye. And in 1998, Eric Kandel in one of his papers wrote, "We're on the verge of the most remarkable scientific revolution." And he wrote that because he was actually talking about the amazing brain we've discovered that we have, that it isn't fixed, that it actually changes. So we can thank Eric Kandel for his studies, who actually opened up the world of neuroplasticity. So we have here the physical brain. Right hemisphere, left hemisphere, with the corpus callosum in the middle. Now, the corpus callosum links the two halves of the brain, and they say there's 50 billion neurons. I don't think anyone's ever counted them, but they've estimated there are 50 billion neurons that go between the left and the right hemisphere. Now, the corpus callosum is very, very important for communication between those left and right hemispheres. And if you cut the corpus callosum, of which they have done in lobotomies, people that suffer epileptic seizures, they have an overabundance of electrical activity between the two hemispheres, and they've cut the corpus callosum, and there was a guy by the name of Henry, quite a few years ago. They cut his corpus callosum, but unfortunately they also cut his hippocampus, and he actually had no long-term memory. Short-term memory, sorry. He didn't have any short-term memory. He could remember things that happened many, many years ago, but you could go in and out of the door 10 times and you were a new person every time. He didn't know who you were. So very dangerous to sever that, because it's very, very close to what is going to be called the limbic system, which I'll tell you about in just a moment. So that's a very important part of our brain. Two halves. The right hemisphere There's debate about do these things actually happen in both hemispheres, but there's enough evidence to say yes, the right hemisphere is basically for the non-verbal problem solving, spatial relations. If you are arty, if you are musical, if you are creative, you have a very highly functioning right hemisphere of your brain. Now there is right brain dominance up to 3 years of age. So that's why babies love music, they love rhythms, they love clapping, they love looking at you because there's recognition there. So he recognises faces, reads emotion. So up to 3 years of age, very highly dominant. After 3 years of age and on, it starts to become more left brain dominant, and the left brain is for our logic. That's why you can start learning to read because you recognise words, and you can start problem solving and analysing, and you put your events in order. If you are a keen organiser, if you like sequences, if you like codes, if you like languages, then you are probably quite left brain orientated. We're just going to focus on one part of the brain mostly, and that's the limbic system. Now this limbic system is very important in the fact it forms the basis of your emotional regulation. There are 4 main areas, though there are other areas in the limbic system as well. So you can see that there's the thalamus, the hypothalamus, the amygdala, and the hippocampus. Now this limbic system is actually known as the impulsive brain because you act impulsively. Welcome. Now when you are born, the brain is formed, but it's not developed fully. It actually is only developed, particularly the limbic system is only developed when it comes in contact with the environment. I'll explain this a bit more later on. This limbic system, it is highly important to our develop of sense of response to our environment. How you react happens in our limbic system. Unfortunately, the limbic system, because it's our alarm system of the brain, it tells us fight, flight, flee. It actually is programmed, for the use of a better word, to react to the negative more so than the positive. That's why a baby cries, because they're in pain. They're wet, they don't like it, they're hungry. So it's actually programmed as a protection system, and it is programmed to the negative more so than the positive. So because it's a protective system, it picks up cues of distress more than it picks up cues of safety. And as we go along, that'll be explained a little bit more. For example, you're walking along the road, you hear a horn. How close is it? If it's really close, you're going to jump immediately away, trying to get out of the way. You see your child going across the road. Your limbic system goes into overdrive because you suddenly become very scared. And so you are actively working. And so the distress is very highly activated. Another part of our brain in that system is the thalamus. And now this is the relay station. For example, if Brisbane was the brain, Roma Street Station or the airport would be the thalamus. All the information goes in through the thalamus. All your sensory information. The only sensory information that doesn't go through your thalamus is your smell. And the sense of smell goes straight to your amygdala. And there are various reasons for that, but I haven't got any evidence of why that happens. But every other sense goes to your thalamus first, where it starts to be processed, but your sense of smell goes straight to your amygdala. Then we have the amygdala. As you see, it plays a direct role in creating symptoms of anxiety. It is the brain's early warning system: danger, beware, threat, unpleasant. If I came in here today and said in a loud voice, all right, sit down, be quiet, take out that paper there, and you are not leaving this room until you have passed 95% of the test I'm going to give you at the end of this talk. You'd go, Corny's laughed. She's got to be joking. But you'd be going, really? This is not what I thought. But if I said to you, and there are armed guards at that door, and you are not leaving until you have passed 95%, some of you would start to get a little bit panicky. If I locked you in the kitchen and said you're not leaving until you've passed, you were getting even more panicky. As soon as we take away control from somebody, our limbic system, particularly our amygdala, danger, beware, threat, unpleasant, fires into action. If I said it with a bit of a wink, you'd go, she's just joking. Calm down. Your amygdala says, I'm okay. But if I was serious and angry and kept up that angry tone of voice, my goodness, you would start freaking out. And if you happen to catch the glimpse of the armed guard with the gun ready, you would not be in a very good state. You'd be wanting to get out. Next region, the hypothalamus. Monitors and controls our internal systems. Important for our sleep, circadian rhythms, our appetite and our thirst. All goes on in the hypothalamus. Remember, all these parts interrelate together. Even though we're separating them, it's like sort of a strand of noodles. We're separating the strand of noodles, but they're all one bunch of spaghetti on your plate. If there's too much overactivity, too much stress in your life, then you have that fight or flight, because it also plays a part in this amygdala. It's all part of our limbic system. But one of the most important parts of our brain system is the hippocampus. Really important part. This is where all learning happens. Your hippocampus, situated in that limbic system, maps and develops context. And if I said to you again, I'm going to give you a test today, just here, it's fine. But if I said to you at school, I'm going to give you a test today, you go, ooh, test on what? Haven't studied. If I said to you in the RTA office, I'm going to give you a test today, the context is I'm probably going to get you my driver's license. If I said to you, if you're in hospital, I'm going to give you some tests today. Different context again. So your hippocampus sorts out the meaning, the context, and it sorts it out based on your prior experience. So if you hadn't been to a hospital and they said, I'm going to give you a test today, you probably wouldn't know what that meant. So our hippocampus sorts out all that memory stuff. Very important. Now, if I said to you, I am going to give you a test today and you're about to board an aeroplane, that probably wouldn't make any sense at all. There's no context behind that. So you wouldn't be quite sure, does that mean I can't get on the plane unless I pass this test? Does that mean it's a test to see if I haven't got drugs? Does that mean I'm getting tested for explosives? Your mind will start getting a little bit agitated. Your amygdala will start working very hard because you're not quite sure what test might mean in the new context. Okay? And if I said to you, if you were over in one of those terrorist countries, as happened a few weeks ago, get off the bus, and if you can't speak the Quran, you're dead. That test of speaking the Quran, life or death, panic sets in. So the contextual relevance is very important. Hippocampus works hard during the night. The hippocampus is busy through the night sorting out all your memories. So everything you experienced, you'll go home tonight, and tonight you'll be remembering what I've told you today. You'll be remembering what happened in church today. You'll know what you had in lunch today. And if you are not having a good sleep, your hippocampus is not functioning. And unfortunately, sleeping tablets stop hippocampal function. They might give us a good sleep, but it's not actually sorting our memories out. So I know some of us think, can't sleep, got to have a sleeping tablet, but you're actually reducing your hippocampal function. So you'll wake up in the morning and you'll remember less. And our lecturer said to us, don't think you need a sleeping tablet before you have a test or get an assignment in, because you won't remember it. So if you can wean yourself off that sort of stuff, it's much better, because you'll actually remember your information much more clearly. We also have the anterior cingulate cortex. That's known as the heart of the brain. This is where we empathise, where we feel regard for others. Make decisions, it acts like the monitoring system. So it increases our level of attention, and it makes available the executive functions. And the executive functions are the things like reasoning, task flexibility, problem solving and planning abilities. And some of our kids in school don't have great executive functions, and there are programs out there now to develop the executive functions in children because they don't know how to reason, they don't know how to problem solve, they don't know how to even answer questions from an analytical point of view. They're very used to just, if I can't see the answer, I don't know what the answer is, there's no answer. Often they want to be fed, and unfortunately one of the biggest things to inhibit our functions, if we watch too much of the television and get fed all our information and don't learn to read and evaluate for ourselves. Okay, then we have the cortical regions, and you see on the picture the pink part of the brain is your cortical regions, and that's where all your thinking happens for the problem solving. It works very closely together with the limbic system. But in a stressful situation, when your body is in fight, flight or freeze mode, when you are in a situation where you are terrified, like I was about 15 minutes ago and still am, your brain doesn't think as well. Okay, so if someone's going into a test, the best thing you can do for your child is going into a test situation at school, good night's sleep, calm them down. One of the biggest bugbears we have today in Australia is the NAPLAN test, and if teachers and staff are putting too much focus on passing the NAPLAN test, stresses kids out, doesn't test all the elements, doesn't test creativity, doesn't test how well they can do socially, but we put an emphasis on the NAPLAN test. 3 days of testing, get real. Unfortunately, I don't think the government has done a lot of brain science work because it actually is not a correct way to even evaluate how a child performs in school. There are too many other elements there. Okay, so what you can do for your children, because the NAPLAN test is a compulsory thing we have to do, but just calm them down. Just tell them it's just another test, it's another day in school. I don't really mind what mark you get. It's actually okay, because I know that you're going to be doing your best anyway. The moment you start to say, I hope you do well in NAPLAN test today, remember it's NAPLAN test, the amygdala is firing. And they are going to do poorly because they are scared they're not going to do well. Makes sense, doesn't it? So there's our cortical regions. They're known as the smart brain. And when there's, as I was saying before, when there's stress, the blood actually flows from the cortical regions into the limbic system, which is our protective system, because it is about survival. You are programmed to survive. It's interesting that if you ever had a car accident, a police officer might say, well, what actually happened? Oh, I just can't think. And no, you can't. So what they're actually doing now, you might write a statement, but they'll go back a week later or maybe 2 weeks later and you do another one, and that's the one they'll take more notice of because they are realising, the police force now, that when you are in a very hypo state of agitation or stress, your brain's not thinking. And so you really can't even remember the facts. And just think about the last time you were stressed out. Could you remember where your wallet was, where your purse was? I've lost my wallet today. Why? Stressed about coming here and presenting this to you. Crazy, isn't it? We do things, and what goes wrong in the mornings when we're stressed? We lose stuff. Can't find our keys. Now, the orbital prefrontal cortex and the ventral medial prefrontal cortex, I forgot to tell you, this is actually where we feel guilty. Inappropriateness. That sort of triggers just behind the eyes here in the very front. And so you'll go, oh, maybe I shouldn't be doing that. And that's what's triggering behind there. That's those two. Now we have neurons. Our neurons are amazing. 100 billion neurons interconnected by 2 million miles of neural highways. The brain of a 3-year-old has about 3 trillion synapses, but they reduce with age. You haven't got nearly that many. You know what? Being over 50, I've got far less than you have. That's a bit of a worry, isn't it? But pruning. Unless neurons are pruned, you would actually have far too many. And this is the problem that they are discovering with children that have autism. They have an overabundance. They haven't had a good pruning of the neurons that they don't need. Chronic stress also does away with too many. So if you have chronic stress, you will actually go into a state of apoptosis, which is cell death. death. Your cells actually begin to die. Neural nets, what fires together wires together. Now this is called the Hebbian principle. Donald Hebb discovered that what the neurons that fire together, they actually stay connected together. So it's like you are going across a paddock of wheat. Beautiful wheat, you do a walk across that paddock and you really can't see where you've walked. But if you do that very same track through the rest of the day, or the next day and the next, what happens to the wheat? It starts to form a path. And you'll very soon see there's an absolute definite path through that paddock of wheat. And that is how this works. What fires together, wires together. All right? Glial cells, really important, like the glue. If you don't have strong glial cells, where there's clustering and communication, and if you have trauma, the structures are weakened. As you can see, glial cells are used for insulation, connections, enhancing communication, and they assist with memory. And there are 10 times more glial cells than what there are neurons. Movement of neurotransmitters. This is that Hebbian principle together. There's our little structure. There's a synaptic space between the two. I'm not going to explain to you how it all works. It will take me all afternoon. And you know what? I still don't get it sometimes. It's very complex. But just take my word for it from the study that's been done that there's a chain of activities that go on called neural firing that connects these presynaptic neurons with the postsynaptic dendrites. What wires together fires together. And the Mersennich principle is what wires... when it stops wiring, they lose interest in each other. So if it's not wiring together, then there's no interest between the neurons and they don't actually connect anymore. All right? There's a very interesting YouTube clip which I was unable to download, unfortunately, that Belinda and Denton sent me about a guy that was riding a bike that was welded up, so it was backwards. So when you turned to the handlebar was set up so that when you turn left, the wheel went right. And when you tried to turn right, the wheel went left. Now sitting here you go, yeah, so? Do you know you cannot ride that bike? Has anyone seen that YouTube clip? It's amazing. I think it's called Backwards Bike or something if you want to look it up. And they could not ride the bike. It took him 8 months of daily trials to ride that bike. He said to his son, I will take you on a trip with me if you can learn to ride this backwards bike. His son learned it in 2 weeks, which just goes to show that plasticity of the brain is much more active the younger you are. So if you want to teach your kids a language, don't leave it too late. I am finding going back to study at over 50 very difficult when I'm in class with students that are as young as my children and they have continued to study and been at that space, just gone on to their masters from doing other study. I find it a struggle. I'm glad I can do it, but it's not without enormous effort. So yes, your brain still changes as you get older, but it takes a whole lot more effort to change because we actually have a lot of patterns set in place. You would ride a bike, you expect it to go this way, but it doesn't, so you fall off. And it took him 8 months to learn how to ride that bike. And then when he went over to Denmark, he tried to get on a normal bike again, and he couldn't do it. He took a long time to get back on the normal bike again. Now he could get on the other bike, the backwards bike, until his phone rang or something happened, and then immediately he had distraction. He went straight back to his implicit memory of riding how he always learnt to ride. Here's neuroplasticity. The brain is not stable. Genetics and environment play a very big part. I want you to talk with your tables just for a moment. Can you name a childhood habit that you might have had that you found really hard to give up? Just give you a minute just to have a breather. Addie said sucking her thumb. What childhood habit did you have that you found really hard to give up? Can you think of something? And if anyone wants to share, that's really good. Okay, have any volunteers to share any childhood habits? Chewing, that was mine too. Chewing my nails. Every time I got stressed, chewed my nails. Anyone else? Slouch. Yes. And how hard is it to actually learn to stand up straight? Same for me, very tall, one to slouch. Exactly. It's interesting because the schemas, they're called schemas or patterns of behaviour that we would develop as a young person, actually become our intrinsic way of doing things. They become our default patterns. The infant brain, that's where memory systems develop. So there is no recollection, no cognitive recollection. You cannot remember passing through your mother's birth canal. You can probably not even remember being breastfed. You do not have any cognitive memory, but your memory was being developed. All right? Remember I said at the beginning that a brain, it cannot actually develop in utero fully. It needs the environment to continue to develop it. So we don't have a cognitive memory, but we do have a memory system. And in those very early years, the memory is developed around whether we feel safe or not. Remember I said at the beginning that you are actually programmed, your limbic system is programmed for protection. So it will immediately go into a protective mode if it feels unsafe. So as a baby, you will pick up very quickly if mum is not there to feed you, if you are left in distress. Your baby remembers those stressful times more so than they'll ever remember that you picked them up and cuddled them for 2 hours through the night and changed their wet pants 3 times. But they will remember they were distressed. And unfortunately, those early memories become our implicit memories that start forming our behaviours that become implicit when we are faced with other things later on in life. Remembering all the time, though, that the brain is plastic. All right. Stages. That's the first. Have a look at the diagrams on the side. Don't worry about the words so much. That's the first part, which is your survival brain. So that's probably the last part to die as well. That's where your breathing and your regulation of your heartbeat and everything like that happens. Then you've got the second stage, which is the limbic system forms. Remember, it's all there. You don't come out with half a brain, but it's not fully developed yet. And then you have that cortical stage, the very end one. Now, the brain doesn't actually finish developing until around age 25. And if you have a teenager that wants to get himself into alcohol, they will actually inhibit neural plasticity. Drugs, particularly alcohol, makes the brain rigid. So it does not have the ability to grow and progress as a normal brain does. Pretty scary stuff when you think of how many kids go binging drinking as teenagers these days. To the age of 25. So what is it, nature or nurture? Your brain develops across the lifespan. Genes are extremely important, but experience actually shapes those connections. Nature actually needs nurture. If you had a very tough upbringing, you were abused, doesn't mean to say you are doomed for life. But it does mean that you have a few pathways there that you will intrinsically go back to. But with neuroplasticity, you can change those pathways because we have choices and the brain is plastic. But your very first early memories, and I can't help thinking of these poor mums, teenage mums that were made to give up their babies because they were pregnant before they were married, and they had their babies taken away from them and they weren't nurtured. and some of these babies that were maybe just left in cots. And all those studies about the babies in Romania that were just left in cots and not cuddled and caressed, just given a bottle, hold the bottle yourself basically, those babies have huge psychological problems because it's your genes are expressed when nature integrates with them. Very quick talk on epigenetics. Epigenetics is beyond the genes, all right? So they study rats, they study all sorts of things to find out about epigenetics. So your hair colour, your eye colour, but there are also traits of chemicals that are passed down. Serotonin, dopamine, and the endorphins are actually passed down from generation to generation. And they did some research on some rat pups, and there's a very special chemical in your brain, it's a hormone chemical called BDNF, which stands for brain-derived neurotrophic factor. Very important chemical that actually reduces the level of cortisol in your brain and the limbic system. So they put these pups into an experiment where some were soothed, caressed by the mother pups, by the mothers that they had, and they noticed that when they put them in a very stressful situation for 1 hour, those rat pups that had been soothed and caressed could actually down-regulate their stress very, very, very quickly. The other group they had in the experiment was, they did to them things equivalent to child abuse. And those rat pups could never effectively down-regulate their stress, and they had a reduced production of BDNF, passed down 3 to 4 generations. They carry the same gene with them. Interesting, isn't it? Maltreatment. Memory. Let's have a look at memory for a minute. There's a couple of memory. First layer, implicit memory between 0 to 18 months. And your experience, it says, activates the firing of the neurons. Your memory is developed by the environment that you were in. So 18 months and beyond, you start to develop layers of your memory. So your very first, between 0 and 18 months, they actually say between 0 and 10 months are the most critical times of a baby's development for developing schemas that are going to really enable your child to grow and progress. Now that's difficult because young mums don't often know what they're doing. Sometimes mums aren't capable of caring for their young babies. Maybe young mums have got postnatal depression. Maybe young mums are sick in other ways and they really have a standoff. They haven't bonded with their baby. Unfortunately, that does actually affect the child's neural development. But remember I said the brain is plastic, but their implicit memory will go back to a default pattern of how they remember intrinsically their treatment as young children. That's why I said in my blurb that very surprised that our kids turned out okay. Okay, implicit memory. Now we have a dog, Bella. Bella's a very cute little pup, but unfortunately Bella was abused when she was a young pup, withdrawn from her mother too quickly, and she is primed. All the time she is primed for attack. Are they going to hurt me? Are they going to look after me? She takes a long time. We have two dogs. One comes up very readily, the other one she stands back until she knows it's safe. So if we move our hands too quickly, even though we've never abused her, she still has that intrinsic memory of what a quick hand might mean. So it's there. Our implicit memories may or may not be consciously aware. So you might be doing something and think, oh, why am I acting like that? Why have I suddenly blown my head and lost my temper? You really don't know, but it could stem back from some of your implicit memories. It doesn't excuse the behaviour, but it does explain the behaviour. And you often would say, well, I've got no idea why I feel that way. And a child will react the same way. A child that feels threatened in any way will develop these memories, and then you'll go, well, why did you do that? I don't know. And obviously, they often don't know why, but something could have triggered off their memories. Here's a very quick diagram for tying shoelaces. The more times you tie a shoelace, you get the pattern of how to do it, and it becomes an implicit memory as well. I showed my students last week the story of Aaron Ralston, who actually the book's called Between a Rock and a Hard Place, and he got his arm stuck in the boulder in blue whatever canyon over in the Utah, and he had to amputate his own arm to actually get out. Fascinating story, very brave young man, and he had to learn to tie his shoes and do all his stuff with his left hand. He was right-handed. Now, you can do it when you are determined to do it. He could have sat down and thought, I'm right-handed, I'm not going to do that, too hard, and never gone on in life. He is now back to his normal self, just learnt new neural pathways to do things in another way. You've got to remember that trauma blocks memory, as in the formation of our accurate memories. Memory is also not just located in one centre of the brain. We haven't got just a space for that and a space for that and a space for that. Sure, there are areas that concentrate on visual learning and integration of language, but it works as a system. So how does the brain operate? There's a word called consistency. If your heart rate is not consistent, if you're breathing irregularly, you'll probably have to go and get it seen to. Okay? We thrive on consistency. It's how we're made. God is a God of consistency. So it's maintaining physiological and psychological consistency. You might like to think of it as a river of well-being. Dan Siegel talks about the river of well-being, with one side being chaos and the other side being rigidity. And you've got to think of the brain as a river and not a rock, because it's always flowing. It's always developing. It's always changing. Is it drought? Your brain will be different. Is it flood time? The brain flows differently. All right? And it also develops into what we put into our brains, which makes the text of whatsoever is pure and just and of good report become very relevant, because what you put into your brain becomes that memory system. So maintaining consistency is very important. We establish a pattern, so when your neurons are connected, it's not like they'll randomly go and connect with something else. Once your neurons are established, they're pretty much, it's different to homeostasis. Things stay exactly the same in homeostasis, but in consistency there's normal. You wouldn't expect your child of 3 to have the same growth as a person of 25. They've still got consistency, but it hasn't stayed the same. Do you understand what I mean by that? Makes sense? There are some interesting psychologists. Seymour, Maslow, you can read them all up there, but Klaus Grauway, he linked personal development theories with neural development. And he said there are basic psychological needs present in all human beings, and when these needs are met, consistency is maintained. He said we thrive. So can you just call out to me, what are the conditions we need for you to survive? What do we need? Food, shelter. Exactly. Water. Exactly. Okay, there's also some psychological needs that we need. These basic human needs are experiences that occur in interaction between the organism and its environment. So this is the genes forming the behaviours, being expressed in our behaviours. So you can have a read of that one there. So you'll see there that they are called neurobiological markers that link the neuroscience. And these are the basic needs. The need for attachment, orientation and control, pleasure, maximisation, distress avoidance, self-esteem and self-esteem protection. Okay, I have an activity for you. As I'm doing the rest of this talk, I have something for you to colour in. And I've got a spare one for you without words on it. Can I just have maybe, thanks Melinda, yeah, we don't have to give one to every child, she'll put them out before. And I'll make something at the end with you with this. That's why you've got pencils and stuff on the table, so I just want you to colour in as we go, and you'll see there's words control, orientation and control, there's pleasure, attachment, self-esteem on that sheet. So colour all the same words, the same colour. Same words, the same colour. And you can keep one eye on the screen And we won't make this until the very end of the program today, so you've got a fair bit of time to colour it in. So understanding the consistency in the basic needs will actually help to explain behavioural childhood issues, some learning difficulties, and adult behaviour issues, because it's all about safety and survival. I'm just putting a table on the board here. I'll explain to you how this table, this is actually in Graway's book, his textbook, and you actually read this table from the bottom to the top. And so the bottom one says experience and behaviour. Our early life experiences set the tone for our behaviours. And those behaviours, you either form an approach behaviour or an avoidance behaviour based on the basic needs, which are above in yellow. So our experiences and our behaviour. So these approach and avoidance are called schemas. And you actually look through your world, that becomes your lens for interpreting and for your reactions and behaviours. So let's look at pleasure first. It's actually the most obvious need. We don't like pain. Pleasure maximisation and distress avoidance. It's on the same continuum. And I'd like you just to tell somebody at your table, what are 2 pleasurable activities you've either done today, did last night, or in the last week? 2 things you actually enjoyed doing. You might want to even write them down. Just tell people at your table, what are 2 things you enjoyed doing? And maybe why you enjoyed it. All right, do you have any ideas? Men over there, what has been a pleasurable activity this last week for you?
I went for a walk this morning.
Excellent. Excellent. Anyone from this table here? Anything pleasurable? Singing this morning. Yeah, good. Back table? Yep, someone else? Joe. Something pleasurable that's happened in this last week.
The 2 things was eating that chocolate.
Oh, yes.
And watching my daughter play touch footy in a break.
Awesome. And let's see the table with, yes, Peter and Lauren. Anything pleasurable happening in your world? There you go. If you are a Queensland supporter, it was a very pleasurable night. If you're a New South Walian, probably not. Front table. Anything pleasurable? Come on the ferry this morning?
Reading
Yep.
and just looking at beautiful scenery.
Good.
Sailing
And the now? Yeah. Ready?
and looking after the grandchildren.
So just by you actually sharing that, you've actually opened up your memory system. And the more you share, especially the pleasurable experiences, your memory system is remembering, and the need for pleasure, and you're actually releasing some very interesting chemicals, endorphins and dopamine. But there are some activities that give a very quick fix of dopamine. Drugs. Cocaine is the top peak in dopamine hit. So once you take it, nothing else will ever give you as much pleasure as that hit of dopamine. So all the psychostimulants, opiates, they affect all the brain regions, nicotine, marijuana, alcohol, and unfortunately even caffeine. It gives you that little hit of pleasure. And it could be the part that you are socialising, relaxing when you drink it, but it actually sends off a dopamine hit. And this is how habits form. When you get a dopamine hit, you want to do it again. And so you get another dopamine hit, and so you want to do it again. And then you get another dopamine hit, and then you are firing those neurons So then they become pathways. So pleasure is very important. But there's also activities that we do that are destructive. The activities, things like pornography. Pornography is a dopamine hit. And that's why you do it. That's why you look at pornography, because it's a dopamine hit. And then your intimacy with your partner is never ever quite as pleasurable again, because you've had the dopamine hit of something that could be better. It could also be gambling. You might feel bad for gambling, as you might feel bad for looking at pornography, but you still get a thrill, and there's still a dopamine hit, and there's still endorphins coursing through your brain, and that's enough of a hit to want to keep you on that track of, I need to do that again. More dopamine, need to do it again. Chocolate cake, or maybe Joe's chocolate. It can be another dopamine hit. Video games is another one. Why do kids get hooked on video games? Because there's a dopamine hit there, and they want to play more dopamine. Pleasure, we strive for pleasure. And when we have pleasurable experiences, we get a dopamine hit. What about this boy here? Not a lot of pleasure in his story. He will actually want to go into a protective. He might want to go and fight the other kids. He might just want to run away. But more than likely, this little boy here will go and withdraw. He will do anything he can because he has to protect that limbic system. It doesn't feel good when your brain is overactive. You get sweaty, your heart beats fast, you're breathing, and you go, oh, I can't do this. So because the limbic system is about protection, he will do anything he can to protect himself. Fighting, fleeing, or he might freeze and go and withdraw. Unfortunately, when he goes to withdraw, when he hides away and doesn't interact, he gets a dopamine hit because he feels safe. And so then the next time he goes to school and he sees the bullies, they might not even be talking to him, but he's going, I've got to run away, I'll go and sit over here. He gets another dopamine hit, woo, off the table, gets another dopamine hit. Aren't these things terrible? Where is it? There it is. And so he goes, and next time he goes to school, he sees them across in the distance, runs away into the library or goes and hides again. Another dopamine hit. So unfortunately, we become trapped in negative behaviours because they're more pleasurable than having to face some of the things here. We'll talk later on in the next session about what we can do. But anything that you do that causes the dopamine hit becomes a habit that starts a neural pathway. All right? And distress, when distress becomes the only release of dopamine, you have things like cutting. You have things like drug taking. Because to cut, that pain of cutting or self-mutilation is actually more pleasurable than the pain of feeling rejected and no self-worth. Because at least I can feel something. Because when you're in so much stress and trauma, you don't feel as you know you should. So the experience of physical pain is actually better than feeling rejected. So they become trapped in a dopamine hit that is a negative, called a negative neural loop. Okay? Attachment need. So important that we are attached to people. We are made social beings. We need physical proximity. But remember I said it like before that maybe the mother is not able to attach adequately to the child. She may be sick, she may have postnatal depression, she may not have effective mothering skills. So the attachment, she might leave the baby crying and crying and crying and crying. So what does the baby do? Sets up a defence to stop the pain. So its memory, even though it can't cognitively remember that incident of being left alone to cry, has set up in its memory system a dopamine hit going, if I just turn over, if I just be quiet, we actually look for ways to protect our limbic system so that we can avoid the pain, and if we are not attached, we will develop strategies to protect ourselves. So you will find people don't want to mix with others. They feel embarrassed. They're not social people. It could be because that in their system, in their intrinsic memory system, there could have been some childhood incident. And remember, I said at the beginning that our memories remember the negative more so than the positive. There were some experiments done with little rhesus monkeys. Now that's a rhesus monkey clinging to a towel wrapped around a wire cage. On the other side is the other wire cage with a bottle, like a teat. Now this little rhesus monkey, it was called the Harlow monkey experiments. Harry Harlow did some very controversial experiments, and thankfully animal liberation movements have actually stopped these experiments now. But it told us a lot about attachment, because the monkeys that emerged from these experiments after 24 months of being isolated from others became away very, very, very severely disturbed. So this little rhesus monkey here, they found that all the monkeys would actually rather cling onto the terry toweling wire frame more than they wanted to go and have something to drink. Attachment is even stronger than our desire for food. So two cages, didn't hardly spend, only climbed onto the wire frame when absolutely had to have something to eat, couldn't wait any longer, had enough to have a bit of sustenance, quickly onto the terry toweling frame. Attachment is vital. And we see it in nature. We see it everywhere. Mothers and babies, families. So what's the neurobiology behind it? Oxytocin and prolactin, they have a calming influence. So it's released by the mother, it builds implicit memory systems, it's positive. And that positive, I feel okay, I feel safe, I'm attached, helps to produce that BDNF, brain-derived neurotrophic factor, which actually counteracts the effects of cortisol. So you have a pattern of I can down-regulate very, very quickly. Remember the rat experiment I told you about at the beginning? So you might be able to down-regulate, but you might find yourself in a situation where you go, I don't know why I reacted like that. I'm just too angry. It's because maybe that your implicit memory hasn't got in its mind how to down-regulate properly. So attachment, close attachment with a mother and baby forms that ability to produce the BDNF, release the cortisol and the oxytocin, the prolactin, and then you can down-regulate. So a child that goes to school, even though they might be confronted with traumatic situations, if they've got a really good support system behind them, and they know how to down-regulate themselves, they might be bullied, but it won't be quite so difficult. Oxytocin is actually known as the love hormone. Now, Bryce, I need to actually show this DVD. If I just press play, will it go? No, it's not. There's a DVD on there. Is it going to go? I wonder. Yep, no. Ring any bells? My family, yes. Okay, need for attachment. We're going to go through a couple of slides because we're going to run out of time. Circle of security. Top hands, 2 hands. Top hand says it's a secure base for our children. Watch over me, delight in me. So when they look in your face, do your children see delight in you? Help me and enjoy with me. Sometimes we are so busy parenting, we forget to enjoy our kids. I'm so busy as a teacher, I forget to enjoy my classroom. Enjoying with kids, a sense of humour, laughing, it actually builds the bonds of attachment. So the bottom hand, when they've gone and explored, they need to come back to a safe haven. So you'll notice a little child in here, if they didn't know me, they will actually come up, they might want to give me something, then they'll run back to mum or dad for security. Then they might come back and explore a little bit further, then they'll run back to safety again. Then they might go a little bit further and explore around the back there, nothing bad's happened, and they go back and they'll look again. That's healthy exploring. If you were not available when they came back, see, I hate this. If you were not available when they came back, then there would be panic and stress. The amygdala would fire, they're not safe, and they will stop exploring. Okay? If they don't feel you approve of them, if they don't feel they are accepted, if you say, what are you doing over there? Get away from behind that screen. They'll never go back there again. But you're also stopping them exploring. So it's protecting them, comforting them, delighting in them. You notice delight is in both the top and the bottom. Not just tolerate children, but actually delight in them. And you need to help them to organise their feelings because they really can't do it because their cortical regions are not developed yet. So they really can't do it on their own. There's just a quick list of good attachment. And part of the attachment we have is mirror neurons. And these little monkeys, the macaque monkeys, Italian team back in the 1990s discovered mirror neurons. They were in an experiment, they were in a laboratory, they had these little monkeys and the monkeys were eating peanuts. It's all very well, the monkeys' neurons, but they were all wired up to electrodes and their little various parts of their brains lighted up with the pleasure they were feeling by eating these peanuts. Very, very interestingly, the researcher came and just started snacking on the peanuts as the monkeys watched, and the very same neurons lit up. So even when someone is watching and you can interpret what they're doing, for example, if I took a sip of water, I guarantee half of you will be thinking, I'm thirsty. I yawn, you'll yawn. I smile, you'll smile. Babies do it all the time. You go and guard a baby, they'll copy whatever we do. That's called your mirror neurons. And all the research has not been completed about the mirror neurons, but there's enough there to know that when we perceive another's emotions, automatically, unconsciously, that state is actually created in us. Remarkable, isn't it? Big implication for parents and teachers, coaches. Did I skip over a few? Maybe I did. Here we go. It's the basis for empathy. I forgot to tell you that. You actually know how someone else is feeling. I don't know if every mum's a sook like I am, but I can't even look at an ad on the TV about Mother's Day. And I get all weepy and all teary and all emotive. Because mirror neurons are playing into what they want you to see. I look at a mother cuddling a baby, I go, oh, it's my mirror neurons working. So we are biologically equipped to be in relationships. We influence others. If I came in here today really grumpy, sour-faced, well, I'm really glad you're here, you would have gone, yeah, sure she is. How do you greet your children in the morning? How, as a teacher, do you go into the classroom and greet your class? When your kids come out of school, get in the car and hurry up. Or are you actually excited and delighted to see them? It plays a big part, our tone of our voice. You might not even say anything to them. You just might be driving, but they can sense what you are thinking and feeling. And they may act up more on you because they are feeling that their attachment with you is being threatened because they're not feeling pleasure by being in your company anymore. It's scary for them. So their amygdala is firing up. Now, I'm not telling you to be perfect parents. I'm just making you aware, as we talked about this at the beginning, that when you're aware, you can be more conscious of what might be happening in your kid's mind. So if your kid acts up a lot, what are they sensing is going on in your family? Our tone of voice behaviours. Little boy yelling at the little girl. Where would they learn that from? The next one is our need for orientation and control. It's intrinsically linked. Now, this does not mean control, I must control you. That is not what this control. It means that when I am hungry, I know where to get food. When your baby is lying in the bassinet or in the cot and they are crying because they've got wet nappies or they're hungry, that they know that they will be fed. They have control. And their control, actually, a most fundamental, what does it say here? No, we're not going back to that one yet. Let's go back. It's one of these most fundamental needs, and so we learn controlling behaviours to reach the desires that we need. All right? So if your baby is not fed, they will start to develop these avoidance strategies. Remember we talked about approach and avoidance? So they'll start to avoid. Maybe they won't cry as loud. Maybe they'll start going into the corner of their cot, and when you come in to see them, they might not want to have anything to do with you. It's called an insecure attachment because they have not now trusting you. They're not trusting that you are actually going to be the provider of their needs. Remember, this happens intrinsically. So the need for control, the last point, is satisfied when we have a maximum number of options. And my example to you, first off, when you came in here, if I close the doors, you must pass the test, there's a gunman out there, you're not leaving until you pass 95%. I have taken away all your control. And when I take away your control, you start to panic. Your amygdala fires up. Those chemicals are released into your amygdala and you go into a bit of a panic. You're going to think of ways to get out of the situation because you don't like not having control. And orientation, making sense of the situation. You've got to remember that our kids are like sponges. How we view reality is our orientation. Self-esteem. Self-esteem is it's a bit higher order of the basic needs because a little baby doesn't really have any self-esteem. Your self-esteem is built by the language you hear from others. I'll say it again. Your self-esteem is built by the language you hear from others. And when your attachment and control needs are met, when you have pleasure in your life, you will have a healthy self-esteem. A positive self-esteem. It's not possible to study these with infants or animals because they don't really have that. Self-esteem enhancement. If there is no self-esteem, the little boy that was bullied, then they start to behave negatively because any amount of attachment with you is better than nothing. So even if you're yelling, that might be better than being ignored. And there's a little model of self-esteem in the middle this is the new model of that theory I gave you. It's the violation of the basic needs. If stress and anxiousness are the result of the basic needs not being met, isolation and loneliness instead of attachment. There is fear and submission if our personal control and orientation is taken. Discomfort and pain instead of pleasure. We feel shamed and humiliated if we lack self-esteem. Neglect, physical abuse, sexual abuse, verbal and emotional abuse, and witnessing family violence. And partaking, a child overhearing arguments scares them out. If you're going to argue, argue in private. Your children will get incredibly scared hearing you argue. And it just does a lot of things to their brains. So we all argue, we all fight, we're humans, but try and do it away from your kids. And it's really good for you to see, Ray and I fight, still do. Our kids, if they saw us fight or saw our displeasure, they also saw us say sorry and hug and say, it's okay. Because to only see the fight but not see the resolution, how does a child learn to solve problems if they're only seeing fighting? So we made sure that whenever we had a fight, they would see us both hug, sit together, arms around each other in the lounge room. Because then they look at you, they look away, start playing, look up, are they still okay? We're still okay. But if you come from a family that's in continual fighting mode, there's always a fear. Who's going to leave? Mum or dad? My friends, they've got divorced families. Is mum and dad going to leave each other? It becomes incredibly scary for them. The younger the child, the greater the impact on brain development if they are stressed. Because infancy is a time of incredible neural growth, and it's when that pruning happening. So what we are not wanting is that pruning of the good positive feelings to be pruned away because they don't feel positive, and only those avoidance strategies to be remaining. And also the teenage years, another critical time for brain development. It's when our personalities, our identities, executive functioning and management skills are taking shape. A chain reaction begins if you're in a stressful situation. Remember, it's life-saving. Oh, we might actually go through this. Just have a quick, I'm not going to read it all out to you, but it's basically, it starts in the thalamus. These are the chemicals that are released. Have a quick read of it. We're not going to spend too long looking at that because we're actually running out of time already. Fight or flight, there's all the body systems that actually react. Prolonged anxiety, trauma. If distressing situations are frequent or continuous, the brain begins to rewire itself to protect. New pathways are formed as neurons fire, releasing chemicals and strengthening protection connections. Why? There's an over-proliferation of the glucocorticoids, which simply put are the stress hormones. Alters energy, causes hypertension, negatively affects our immune system. You will feel sick if you have been stressed. Maybe a child doesn't want to eat. If you just had a big fight with the boss at work, you won't want to eat either. Results of prolonged stress. Actually unable to adapt to changes in environment. Neuroplasticity is hampered. And in severe cases, there is cell death, which is called apoptosis. And it's interesting, the last 2 points, for the fMRI scans they've done, they've actually seen that children that have come from very stressful families, they have a smaller hippocampal volume and a larger amygdala. Because what's been overworked? The amygdala has been on constant alert. It is larger than normal and the hippocampus is smaller. Consistency in kids. Security, nurturing, understanding, they will have approach tendencies. Put downs, criticism, dysfunction, threats, disappointments, avoidance.